Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 183. Please turn to it, page 183, problem number 215. Problem number 215 is something that we did yesterday on day number 245. This is a continuation of the similar problem, not the same problem, a similar problem. I'm calling it 215 bonus problem. Here's how the problem goes. It is very similar to what you will find in the book, same idea. We have three people, A, B and C. We are told that they are working independently to solve a problem. They're working independently. In other words, the odds of one person succeeding or failing at the task has nothing to do with what the other two people are doing. We are told that the likelihood that each of these persons will succeed is 1/4, 1/3 and 3/5 respectively. Question simply is, how likely is it that no one will succeed? How likely is it that no one will succeed? Well, here is our A, B and C. What are the odds that A will not succeed? Well, we are told that A has 1/4 chance of being successful. If he has 1/4 chance of being successful, it stands to reason that he has 3/4 chance of not being successful. We are also told that B has 1/3 of a chance to succeed at the task, which means B has 2/3 chance that he will fail. Similarly, C, we are told, has 3/5 chance. If he has 3/5 chance of succeeding, it implies that he must have 2/5 chance of failing at the task. That's it, that's our answer, that's how simple it is. That's it, we are done. These three will cancel out with this 3, these two will cancel out with 4, and the answer is 1/5. In other words, there is a 20% chance that they will all muck it up. They will all fail. Muck it up with an M, not an F. Let's do one more, shall we? Here's the next question. Question number 2. How likely is it that only A will succeed? How likely is it that only A will succeed? Well, let's find out, shall we? Here is our A. Let's do it here. A, B, and C. How likely is it that only A will succeed? Well, what are the odds that A will succeed? The odds that A will succeed, we are told, is 1/4. And since we want only A to be successful, the odds that B will fail, same as before, he has 1/3 chance of being successful, so he has 2/3 chance of failing at it. Similarly, C has a 3/5 chance of succeeding at it, he has 2/5 chance of failing at it. Same exact thing as before. This 4 will cancel out with these two, and we are left with 1/15. These are pretty straightforward, simple problems if you understand the concept behind them. There's not much in them. Let's do one more. How likely is it that A and B will succeed? A and B will succeed, but not C. Again, it's very straightforward. A and B, we want to be successful. What are the odds that A will succeed? A has 1/4 chance of being successful. What are the odds that B will succeed? B, we are told, has 1/3 chance of being successful. And what are the odds that C will not succeed? Well, C has a 3/5 chance of being successful, therefore he has 2/5 chance of failing at the thing. And that's all there is. Cross out the 2 with the 4, and we're left with 2 times 3 is 6, 1/30. 1/30. In other words, not bloody likely. Not bloody likely that A and B will succeed, but C will not fail. Why? Why not very likely? Well, you look at the numbers here. We are told in the beginning that C has a 60% chance of being successful. He has the highest probability, highest odds of being successful at this task. A, we were told, only has 25% chance. B, we were told, only has 33% chance. Therefore, the odds that the people with the lower probability of being successful at the task will actually succeed and the person which we assessed as the most competent will actually fail, is very unlikely. It's 1 out of 30, 1 out of 30 chance. That's all. 1 out of 30 chance is if you multiply the top and bottom by 3, now we're talking about 3 out of 90, which is approximately 3 out of 100. It's around 3% chance. It's not very likely. It's not very likely that the person who we assess to be most competent at the task will actually fail, and everybody else will actually do the job. Let's do the next one, shall we? Number 216. We're done with this one. We're done with this one. Number 216. In number 216, we are given an equation here, and we simply ask what could be the value of x. We are told 1 over x minus 1 over x plus 1 equals 1 over x plus 4. And then the question is, the x could be what value? I need to erase it. Then x could be, and we are given the answer choices A, B, C, D and E, 0, -1, -2, -3 and -4. Oh, that was very nice of them. All in consecutive numbers starting with 0. But the concept that they're testing here is this. Any number divided by 0 is undefined. It doesn't exist. And this is how we write it. Any number, doesn't matter. Any number n, if you were to divide it by 0, that quantity is undefined. It's infinity. And therefore we cannot divide a number by 0 and expect to have some concrete answer, some concrete number. It's not defined, it's undefined. Therefore, in this equation, anything that makes the denominator 0, cannot work. For example, what would happen if x were 0? If x were 0, this quantity will become undefined because it will be 1 over 0. Therefore, x cannot be 0. If you look at this part, the second term, we have 1 over x plus 1. What happens if x were -1? If x were -1, it's a hypothetical statement because it cannot be. If x were -1, -1 plus 1, again will end up with a 0 in the denominator. X cannot be -1 in this equation. Similarly, x plus 4, we are told, is the denominator of the other side. What happens if x happens to be 4? If x happens to be 4, or rather -4, if x happens to be -4, we'll end up here with -4 plus 4 with a 0, which tells us that x also cannot be -4. X cannot be -4. At this point, what I've seen sometimes, some people immediately, without actually looking at the answer choices, they immediately have this uncontrollable urge to actually start solving this equation. They set it up in a complicated quadratic equation and try to solve it. Don't do any of that. At this point, we are left with only 2 here. Try them out and see what happens. Ask yourself, could x be -2? Let's try it out and see what happens. Well, if x were -2, we'll end up with 1 over -2, 1 over -2, minus 1 over -2 plus 1 equals 1 over -2 plus 4. Now, as long as this equation holds, then x could be -2. Obviously, we cannot have 2 right answers. So if this one works, the other one would not work, and I'll show you one way or the other, okay? So 1 over -2 is just -half. Here we have a -1 over -2 and a +2 is a -1, which will become +1 here. And here we have 1 over -2 and a +4, that's a +2. So what happens here? This part here, 1 over -1, and with a negative sign in front of it, it just becomes +1. So on this side we'll end up with -half, a plus a 1. But there you go, 1 minus a half 1 minus a half equals half. So that does work. X could be negative 2, which means it must be true that x cannot be negative 3 in this equation. And we'll show here that x cannot be negative 3. X cannot be negative 3. Let's see. 1 over negative 3. 1 over negative 3 minus 1 over negative 3 plus 1. Negative 3 plus 1 equals 1 over x plus 4. X is negative 3, so it's negative 3 plus a 4. Here we end up with negative 1/3. Here we end up with negative 1 over negative 2. And here we end up with 1 over 1. Because negative 3 plus a 4 is a 4. That's just 1 over 1, that's just 1. And this side, as you can clearly see, is not 1, because this negative, and here we have 1 over negative 2, it will become positive half. In order for this equation to hold, this quantity should have been positive half. Positive half plus a half would have given us 1. It's not a positive half, as we can see here, it's a negative 1/3. C cannot be negative 3. C cannot be negative 3. And therefore the answer is B. So one more time, we crossed out right off the bat. The first three of them should take few seconds, split seconds, to figure out that 3 out of these 5 answers do not work at all immediately. X cannot be 0, x cannot be negative 1, x cannot be negative 4. And then you try out one of the twos here and see which one works. That's all it is. Let's do the next one, okay, shall we? Next problem is also pretty straightforward, 217. Let's get it out of the way. Every time I turn here after I finish the problem to get a sip of my tea here, and I left my cup in the other room, so I cannot have my tea. Let's do the next problem. So remember, any number divided by 0 is undefined. It cannot be done. 217. In 217, we are told, we're given a whole bunch of fractions, and we are asked to evaluate the value. One over 2 raised to negative 1 over 4 raised to negative 2, and 1 over 16 raised to negative 1. Now, as you look at the answer choices, we see that these are expressed in terms of fractions, 1/2 and 1/8 and so forth. So that's what we're going to do. I'm going to tell you actually, just to show you here, I'll tell you actually what happened when I first looked at the problem, because I wasn't paying attention to the answer choices. And here is what I arrived at. I need the room. You see, 1 over 2 raised to negative 3 is same as negative 2 raised to negative 1, or rather 2 raised to negative 1 raised to negative 3. This is same as 4 raised to negative 1 raised to negative 2, and this is same as 16 raised to negative 1 raised to negative 1. And that of course boils down to 2 raised to positive 3 times 4 squared times 16. And I thought they were going to give us one large number, which is what they were looking for. I thought they were looking for 8 times 4 times 16, whatever the hell that happens to be. Or perhaps they're looking for the power of 2, like this. 2 cubed times 4 squared is same as 2 to the 4th, and this would be 2 to the 4th again. And that will give us 2 raised to 3 plus 4 is 7, 7 plus 4 is 11. That would give us this. But that's not what they're looking for. Well, actually, I just realized that we had done at this point also. 2 raised to 11 can be written as 1 over 2 raised to negative 11. There you go, that's your answer. 1 raised to 2 raised to negative 11. So that's one way of doing the problem. If you went down this part and you realize that the answers are not written in this form, then you can just flip it and make it a negative power. Another way we could have solved this problem from very beginning is to leave the fractions the way they are into 1/2. So 1 over half 1/2 to the negative third, and 1/4 can be written as 1/2 raised to 2, and then it's being multiplied by -2 outside. And then 1/16 is same as 1/2 raised to 4 being multiplied by -1. And will give us the same thing, obviously. So here we have 1/2 raised to -3, here we have 1/2 raised to -4, here we have 1/2 raised to -4. And as you can see here, 4 and 4 is 8, 8 plus 3 is 11, so it's -11, same as this one. That's it. No difference. No difference. I will see you tomorrow, okay? Bye now.